This is section 16.3, matrix multiplication. So far we've added matrices, subtracted matrices, and multiplied matrices by a scalar, which is a number. What if we want to multiply two matrices together? Can we do it? Sure, under some circumstances. Two matrices A and B can only be multiplied if the number of columns in A is the same as the number of rows in B. In other words, when we write out the dimensions of the matrices, like this, A, the matrix of dimensions m by n, and B is a matrix of dimensions n by L, the number of columns in A, which is the second number for A, must equal the number of rows in B, which is the first number for B. Those two middle numbers must be the same. If those two middle numbers are the same, then we can multiply A and B, and the product that we get will be a matrix of the size m by L, the two outside numbers. Okay? Only if those two middle numbers are the same can we multiply them. So, for example, can these matrices be multiplied? Number 1, what's the dimension of that? That is a 1 by 3 and a 3 by 1. Since the middle numbers are the same, I can multiply them and I'll end up with a 1 by 1. So that's doable. What about number 2? I've got a 2 by 2 and I'm multiplying that by a 2 by 3. The middle numbers are the same. I can do it. And I'll end up with a 2 by 3, the outside numbers. What about number 3? I've got a 3 by 2 and then I've got a 3 by 3. Can I do it? No, sir. Those middle numbers are not the same. Cannot do it. Not possible. All right. So, if they are multipliable, how do we do it? How do we multiply matrices? Well, that's an excellent question. It is not as simple as just multiplying the components. That does not work. Instead, we multiply a row of the first matrix by a column of the second matrix. It will make more sense as you watch me do an example. You need to watch and listen. First of all, can I do this? Yes, it's a 2 by 3 and then a 3 by 2. Middle numbers match. So my answer is going to be a 2 by 2, and that's important to know. That I'm going to end up with a 2 by 2. Well, in my 2 by 2 answer, the top left corner, the number that goes in the top left corner, I'm going to obtain that by multiplying a row of the first matrix by a column of the second matrix. Well, which row and which column? That top left number is in the first row, first column of my answer. So I'm going to multiply the first row of the first matrix by the first column of the second matrix. Here's how that works. Watch. And I'll write out the steps for you. 3 times negative 1 plus 1 times 2 plus 0 times 5. Do you see that? 3 times negative 1 plus 1 times 2 plus 0 times 5. I'll work that out in a moment. If I move down below that one, the one in the bottom left corner is now in the second row, first column. So I will multiply the second row of the first matrix by the first column of the second matrix. That goes negative 1 times negative 1 plus 4 times 2 plus 2 times 5. Again, I'll work that out in a moment. I'm just writing it all out this first time so you can see how I'm doing it. Now in my 2 by 2, I move to the top right corner. That is now in the first row, second column. So I will multiply the first row of the first matrix by the second column of the second matrix. So that's 3 times 0 plus 1 times 3 plus 0 times 0. And I move to the bottom right corner, which is the second row, second column. So I multiply the second row of the first matrix by the second column of the second matrix, obtaining negative 1 times 0 plus 4 times 3 plus 2 times 0. Now let's simplify that. In the top left corner, I've got negative 3 plus 2 plus 0 Negative 3 plus 2 is negative 1, and then the 0 doesn't matter. Moving over to the top right, I've got 0 plus 3 plus 0, that's 3. Bottom left, I've got positive 1 plus 8 plus 10 makes 19. And then the bottom right, I've got 0 plus 12 plus 0 is 12. So notice my answer is the 2 by 2. Make sense? Probably not. Let's do another one. Let's say A is the matrix 3, negative 4, 2, 5, B is the matrix 4, 1, negative 2, 3, 6, negative 1, and C is the matrix negative 3, 0, 1, and 6. Let's find each of these quantities. First, AC. So I'm going to write them out in order. A is 3, negative 4, 2, 5. C is negative 3, 0, 1, 6. Can I do it? 2 by 2, 2 by 2, middle numbers match. I can do it. Okay, and my answer will be the outside numbers 2 by 2. Alright. In this 2 by 2, let's start with the top left corner, which is in the first row, first column. So I'll multiply the first row of the first matrix by the first column of the second matrix. That means I start with 3 times negative 3 plus negative 4 times 1. That's negative 9 plus negative 4, which is negative 13. Move over. First row, second column. First row of the first matrix by the second column of the second matrix. 3 times 0 plus negative 4 times 6. That's 0 plus negative 24, which is negative 24. Second row, first column. 2 times negative 3 plus 5 times 1. Negative 6 plus 5, negative 1. Second row, second column. 2 times 0 plus 5 times 6 is 0 plus 30, which is 30. So that was A times C. How about C times A? Now you might think, well, that's going to be the same thing. Let's see. C times A means negative 3, 0, 1, 6 times 3, negative 4, 2, 5. Again, I can do it. It's a 2 by 2 times a 2 by 2. The middle numbers match, so my answer will be the outside numbers 2 by 2. All right. Top left corner is first row, first column. So negative 3 times 3, which is negative 9, plus 0 times 2, which is 0, so negative 9. Already I can tell these are not the same. AC is not CA because that top left corner is not the same. So it turns out matrix multiplication is not commutative like regular multiplication of real numbers are. Interesting. Alright, top right corner, first row, second column. Negative 3 times negative 4 is 12, plus 0 times 5 is 0. I get 12. Bottom left corner, second row, first column. So 1 times 3 plus 6 times 2. That's 3 plus 12, and that's 15. Bottom right corner, second row, second column. 1 times negative 4 plus 6 times 5. That's negative 4 plus 30, which is 26. How about A squared? Well, what does it mean to square something? It means to multiply it by itself. So I do 3 negative 4, 2, 5 times 3 negative 4, 2, 5. What I do not do is just square 3, square negative 4, square 2, and square 5. Because to square something means to multiply by itself. So I have to multiply A by itself. Again, I can do it here because it's a 2 by 2 times a 2 by 2. Middle numbers match. So I end up with a 2 by 2. Top left corner, 3 times 3 plus negative 4 times 2. 9 plus negative 8, 1. Top right corner, 3 times negative 4 plus negative 4 times 5. It's negative 12 plus negative 20, negative 32. Bottom left corner, 2 times 3 plus 5 times 2. That's 6 plus 10 is 16. Bottom right corner, 2 times negative 4 plus 5 times 5. Negative 8 plus 25, 17. B squared. That'll be 4, 1, negative 2, 3, 6, negative 1 times 4, 1, negative 2, 3, 6, negative 1. Check it. 2 by 3 times a 2 by 3. Can't do it. Not possible. That's all I write, and I'm done. Why can't I do it? because the middle numbers don't match. Here are your immediate practice problems. Let D be the matrix 2, negative 1, 3, 6, and E be the matrix 4, negative 2, 1, 0, 5, 2. Find DE, D times E, and find D squared. That is the end of section 16.3.